should do it. Okay, let's get to work. We've got our functions on polynomials. Here's the way we represent such polynomials. Just for fun, let's change that. M is going to be the degree, or -1 if poly equals 0. So when we print poly, greater than or equal to reduced degree. That's still valid. When we allocate because of all this work, you might be wondering why I'm bothering. It's just in terms of being an array of coefficient, that kind of having n mean the number of elements in the array makes sense, but if you want to think about these things in terms of actual polynomials, it's better maybe to have n mean something mathematically. It's pretty arbitrary anyway. N right now means it's the last value that makes sense, the last value of I, which makes sense. Before it was the length. It's pretty interchangeable, except that okay, so here we have one ISO equation, you know, at the degrees, the degree of the product is the sum of the degrees. But when you implement mathematical things, one of the crucial tasks you have to perform is you have to figure out if the code is right or not. So sometimes it's nice to line number. Sometimes it's nice to make that as straightforward as possible. You know, sometimes you've got some really complicated mathematical idea, and it has to be just right. because it's critical to your application, and it's an idea that's very hard to understand, and one of the reasons you write a program is to understand it. So by making things kind of canonical, you know, by not straying too far from, like, for no good reasons from the conventions in mathematics, it makes it easier because you can look at just examples of the mathematical idea already worked out in mathematics and try to see if your program reproduces the same behavior. So one thing you might have noticed or might not have noticed is that we do create a lot of polynomials right now in this with our functions. So we should maybe make a function to create such polynomial. Something like that. It doesn't matter in this case because we're not going to deal with big polynomials. If we were, we would probably implement it differently. So now there's just this function that makes that returns a polynomial where everything is set to 0.